Hello, my name is Corey Roche. I'm the ROV instructor, one of two. Richard Vandervoort would be the other one. And between us both, we probably have 55 to 60 years experience. Richard with a bit more than me, obviously, because he's older. And so, a bit of background about myself, I guess. I'm originally an aircraft maintenance type of dude. Alright, so I went to school in the late mid-90s for that, up in Gander, and probably worked at it for 7 years. And 5 years with oceaneering at the ROVs, a couple of years with Baker Hughes, repair and maintenance technician for directional drillers, and then ROV instructor for the last 8 years. So there you have it. You're in safe hands, and Richard's been at it since the early 80s. Alright, so I do believe he worked out on an Ocean Ranger, and he's been in a wasp suit, so we'll see a wasp suit later on, very soon. Alright, so let's get started. Underwater vehicle types can be divided in 4 main groups as listed below. HOV, human occupied vehicles, manned submersibles; UUV, unmanned underwater vehicles; AUV, autonomous underwater vehicles; ROV, remotely operated vehicles. ROV is the industry standard acronym for remotely operated underwater vehicle to distinguish it from any other remotely controlled vehicle which operates on land, sea, or in air. And this course will focus primarily on remote operated vehicles, and that being said, mostly work class. Okay, so a remote operated vehicle, ROV, is essentially an underwater robot that allows the vehicle's operator to remain in a warm, safe, comfortable environment while the ROV works in a hazardous environment below. And here we go. The ocean represents 97% of the world's biological habitat and supports the life of approximately 50% of all species on Earth. It covers 70% of the Earth's surface. It is in the subsea mantle that we reach for aggregates, places of gold and diamonds, petroleum and gas deposits, and food. Currently, polymetallic sulfides and nodules from the seafloor are in the process of being harvested in several remote areas of the world. So that would be like Namibia, which is off Africa, right? Below Angola, north and east, I guess, of, or north and west, I'm sorry, of South Africa. And Papua New Guinea is the only 2 places I know about subsea mining. So ROV and AUVs are essential for this work, both in exploiting these reserves and also in understanding and protecting this vast environment. So T.S. Eliot, he's like an author, poet, playwright back in the day, and he just says we shall not cease from exploration, and the end of all our exploring will be to arrive where we started and to know the place for the first time. So I'm not going to get too much into him. An ROV is an underwater robot connected to the surface by means of an umbilical or tether system. In contrast, AUV does not require any connection to the surface or communication with its human operators in order to function. So the ROV, which I teach mostly, just think on like an electrical lawnmower or any type of power tool. So what the biggest hang up is the cord, the tether. So the same with this, you got an underwater robot that's got a tether. Just think on an extension cord, many hundreds of meters long, if not kilometers, okay? So the tangle it can be. So with this, power and control signals are sent down to the ROV, with video, telemetry, feedback, and sensor data transmitted back to the surface. The surface controller can be as simple as a joystick controller with a single video monitor connected directly to a 3 kilogram free-swimming tethered ROV, or as complex as a fully outfitted fly-by-wire commercial 330 horsepower Class 3 ROV system utilizing a tether management system, 4,000 meter winch large assembly, that's what launches it off deck, launch and recovery system, complete with 3D videos and an array of sensors and subsea tooling packages. So that would be like depth sensors, right? Temperature sensors, probes for rusting, CP, cathode protection, sonar, obviously. An increase in size of the ROV necessitates an overall increase in size of the ancillary umbilical, lars, and winch system. An increase in size or capacity to nearly every support component, along with a requisite substantial increase in cost. So the bigger the ROV, the bigger the footprint, the bigger the cost. Okay, more copper. And we'll just go here now to what's the difference? AV and ROV. So here's a National Ocean Service. Alright. NOAA government, so you can Google that. Just read through it yourselves. And here we go, another website for you. The Liquid Grid. Alright, we got just like a little family tree here. Alright. There you go. Manned vehicles. Unmanned. Goes on and on and on. Okay. So something for you to just I'll go back up to it and bring it up for you. Alright. Just look at it there. I'm just going to pause this now for a second. Alright, so I'm back again. So prior to the advent of ROVs, humans performed often dangerous work of gathering food, subsea salvage, and construction. Freediving was prevalent in many cultures around the world, with records going back as early as 4000 BC. And before the Common Era or before Christ, whatever you prefer. Alright. Aristotle makes reference to a mechanical device that enabled divers to breathe surface air in the 5th century BC. Pearl collection in Ceylon and Japan, 1000 years BC. So Ceylon is Sri Lanka. Shell and sponge collection in Korea. Oyster diving in the Mediterranean. Free diving was a commercial venture, whether it be for food, domestic products, or marine salvage. So here's some old pictures. Japanese pearl divers are called ama, which literally means sea woman. And 16th century Dutch pen and ink drawing Mediterranean pearl divers. So amas, they're still on the go today, using free diving techniques and dive to depths of 30 meters, about 100 feet, for up to 5 minutes. And the Towa Diving Apparatus Company in Minasenji, Japan, designed a pearler-style helmet, copied from the Hinky pearler helmet above right. Alright, so big and heavy, we'll say. So atmospheric diving suits were developed to allow people to dive without the need for decompression. In 1715, John Lethbridge constructed a diving engine, which was basically a wooden barrel with armholes and a glass window that could be lowered to about 18 meters. Here's a modern replica built by Henry the Laws of Comex. Alright, so you can see his arms, porthole, right? Tongs to do his work. Looks like there's a tether there. Pretty nifty. So atmospheric diving suits. After testing the machine in his garden pond, John Lethbridge went on to salvage 4 English men of war, 2 Spanish galleons, and the Dutch vessel Slaughterhouse, which had sunk off Madeira with over 3 tons of silver. He could remain submerged down to 10 meters with ease and 12 meters with difficulty for up to 6 hours, with the surface bellows providing air. John became very wealthy as a result of his successful salvage machine and process. And a bit more history for you. In 1917, American Benjamin F. Leavitt built the first self-contained ADS with his own air supply, telephone, and ball bearing joints. It dived to 110 meters and was used to recover iron ore and copper from sunken ships. By 1952, the ADS suit, atmospheric diving suit, was incorporating high pressure cylinders to provide breathing, air and buoyancy, had hydrophones for communication with surface tenors, had interchangeable instruments to place on the manipulator arms, enabling it to perform more complex subsea work. So 1 atmosphere WASP suit was patented novel technologies to waterproof seals and joints, which could withstand pressures to 550 meters in depth. And there was no decompression was required. And the downside was that it was awkward with limited abilities. So, like I say, Richard supposedly was in one of these, and a couple other construction divers I knew used them. Okay. So here's the back side. The WASP also had an optional thruster pack which gave it greater independence and maneuverability. It was still tethered to the surface. This was designed and fabricated in Vancouver, BC. The actual diver in a gym suit was dropped 620 meters to the sea floor when the crane wire snapped immediately after the launch. He was able to attach a rescue crane wire to himself and was safely recovered to the surface. He retired from atmospheric diving suits diving the end of that day, as you can well imagine. Quite a fright. So ADS, so know this, are good for minute work. They are less labor intensive than saturation diving, require less deck space, no recompression chamber. However, they had limited tooling, handling capability. Time of death is limited to the diver's psychological endurance. The key drawback is that a human being is still being placed in a highly dangerous environment. So, you know, what's behind you, right? We'll get into that later. And I think the pressure actually will play havoc on your bones. So here we are, the modern evolution of the atmospheric diving suit, right? From 1919 up to 2005. And we'll just give you this little... We'll play that.
1,000 years ago, a ship sank carrying treasures and works of art.
Just a little video blurb of what's on
the
the gun.
team are using a new underwater diving suit called the exosuit, which enables divers to descend to more than 300 meters underwater and stay there for hours without having to decompress on the way back to the surface. The 240-kilo exosuit features 1.6 horsepower foot-controlled thrusters and 18 rotary joints in the arms and legs to provide freedom of movement. Although the exosuit looks like a spacesuit, and probably a very complex one, in reality it's quite simple. It's not about diving anymore. It's actually driving a submarine which we're wearing.
Alright, so there you go. You can just, you know, go on YouTube and atmospheric diving suits or WASP suits. Google it, alright? So I'm not going to get in this. You can read this yourself. It's 1994. So benefits of utilizing ROVs: not placing humans in danger, highly reliable, and time at depth is relatively unlimited. Design and function limited only by the intended task and the amount of funds an organization is willing to pour into it. Can be specialized to perform almost any task a human can do. Large payload and tooling capability. ROVs have the attributes of a brain, the human operator, attached via a long nervous system, the umbilical, and brain hydraulic power, which is provided by heavy-duty electro-hydraulic power systems to thrusters, tools, and manipulators. More cost-efficient, approximately one-third the cost of such divers can operate much deeper depths than the atmospheric diving suits or divers. So know this page. Evolution of the ROV. Austrian Navy. Torpedo. Where am I going to? War. War always seems to bring out the best in technology for some reason with the human race. And I'm not saying that in a good way. So first concept ROV was a torpedo designed by Captain Giovanni Lupus of the Austrian Navy and the Briton Robert Whitehead, who ran a marine engineering firm in the Austrian town of Fiume, we'll say, on the Adriatic Sea. The work led to 1868 to the first automotive torpedo, where automotive meant self-propelled and had no other connection to the present concept of an automobile. Right? Automotive means self-propelled back then. So here it is. Right, 4.9 meters long, carried a warhead of 35 kilograms. Gun cotton had a range of 360 meters with a speed of 8 knots. Now you can go on like the History Network and Google all this, or some type of war channel, right, and it'll get into the evolution of torpedoes, which, you know, we're not covering torpedoes, we're covering ROVs, and it gets in how like gyroscopes and compasses were put in them. Alright, so feel free. So Nikola Tesla demonstrated an early remotely operated boat in 1898 and hypothesized, you see there, the first of a race of robots, mechanical men, which will do the laborious work of the human race. So just think of now, you know, your little carpet cleaners, the automated vacuums, right? I think they got a lawnmower now. Just think on the old Star Wars movies from the 80s, right? Where the little, in the 70s, where the little robots were going around, making sure all the dust was clean. So it's an evolution, right? And just think on like your assembly line plants. So robots are the way of the future. Okay? And you can actually Google yourself robots and see what they can do now. Backflips, somersaults, all this type of stuff, rolls. You can try to knock it down, it'll stand up, right? It'll balance itself. So know this here for multiple choice probably. World's first true ROV called Poodle was developed in 1953 by French engineer Dmitry Rebakov. An experimental design to study how an underwater motor with a propeller reacts when controlled from a distance. So Rebakov with some of his inventions in 1953. And we got the Cutlet here, Royal Navy, in the mid-1950s to retrieve practice torpedoes and mines. Once again, war. Okay, it was tethered from the surface by an electromechanical umbilical that carried electrical power, video, and data signals between the operator and the vehicle. So we're getting into the rectangular cube shape of an ROV here now, okay? And the U.S. Navy developed their own RV called Curve, or Cable-Controlled Undersea Recovery Vehicle. So you got your acoustic, right, recovery buoy, propulsion units, hydraulic system, the claw, optical equipment, right, all the basics. So the next generation Curve 3 RV below was involved in another much more dramatic rescue 7 years later. On August 29, 1973, during recovery from a dive after cable bearing operations between Canada and Ireland, a tow line fouled on a knot of the Pisces 3 after hatch turned it and lifted the hatch off. The submersible Pisces 3 with a 2-man crew sunk stern first to a depth of 480 meters off the coast of Ireland near Cork, and Pisces 5, which is airlifted by Canadian Air Force's Hercules from Halifax to Ireland, and Pisces 2, which was shipped to Cork from Swansea, UK, responding both located the sunken submersible. Pisces 5 located Pisces 3, but was unable to attach the lifting line. Second time after a snap hook unsnapped itself and got tangled on a thruster garret ring. Finally, after being stranded on the ocean floor for 76 hours, Pisces 3 and its 2-man crew were recovered safely to the surface despite a storm that had been raging for several days. Dr. James Farron writes, it clearly shows the crucial role played by the Canadian Air Force, the Canadian Navy, the Teleglobe, Canada and Hico, crew led by Al Trice and Mike McDonald. This grueling, stressful, and ultimately successful operations. Canadians had answered the call of duty with distinction. So you can, actually, I'll give you a little thing here now, a little blurb on it. Just pause this for a second. And here we go. You can Wikipedia it. That's a good enough article for you. Alright, it gets into it here. So once again, good old Wikipedia. Now the bad thing about Wikipedia is you gotta watch it, the sources. But for the most part, it's pretty good. I'm after verifying many things, through old encyclopedias back in the book days. Okay, so take everything with a grain of salt, but discover yourself. Okay, so here's the boys. Assisted two Canadian men submerged place 2 and 5 by inserting lifting lines in the tail spear that eventually recovered the last sub. So no time on our side. It's not much on our part, so I would prefer that you look it up yourself. So there's the boys. Scary, I would say, though. 72 hours, was it? Down there now without waiting on someone else to save you. So here we go. Let's change this here. 1950s, the oil and gas industry moves offshore. The need for commercial divers grew as the oil and gas industry moved offshore. Many small companies were formed, primarily by the United States Navy divers, utilizing United States Navy technology to help from West Coast abalone and other civilian divers. Companies grew larger, operations became more technical complex, and the demand for new technologies increased. So oil rigs, right? Fairly complex platforms, okay? So surface supported diving. We'll get into this for briefly now. So divers were an essential component of the process. However, utilizing divers were expensive and labor intensive. It presented logistical difficulties. Operations were depth limited and required decompression time. In addition to the winches, overboarding platforms, diving bells, and all the dive equipment itself, there was a necessary recompression area that took up deck space. Dive operations also required a lot of support personnel. Alright, so what I can say about this deck space is at a premium out there. And, you know, so the ROV can take the place of many men, and you don't have to worry about life, okay? So here we go. Divers travel from underwater habitat at the what's on the go here? There we go. Divers travel from underwater habitat to dive work site to the decompression chamber in a pressurized diving bell. So there you can see it there. Okay. So the diver, right? Lots of umbilical on him too. Seems pretty tight for a person to go inside. So what's wrong with this picture? Alright, so what's wrong with this picture? 180 meters down, that's 596 feet or something like that, I do believe. Okay, so 596, almost 600 feet down. North Sea wellhead in the dark. Hopefully he's with a couple of other divers. And it got to play on your, got to play on your psyche. What could be behind you? Right? Sharks, squids, octopuses. Just got to, and the pressure too, right? But just in the dark working. It's got to be hard on your mental, emotional stability. So the event of reliable subsea voice communication systems, surface supplied hot water suits, and advanced mixed gas equipment made diving a bit more comfortable and permitted the divers to work for longer time periods. However, longer saturation divers and diving bells in underwater habitats required the divers spend days on a ship or rig in a pressurized decompression chamber after a dive. It was damp, cramped, and uncomfortable. Hot food and drink supplied through pressurized hatch chambers. So it don't seem like there's too much room. Right? Downside of saturated was that it was depth limited and required decompression time. It was also rather dangerous. That is what we've seen with, earlier. So alternatives to man hyperbaric diving. So manned diving bells, which were tethered at maneuverable at depth, Their capabilities were limited to the tools they carried and the oxygen available for the crew of 1 to 3 people. This is an early manned submersible to carry passengers on aquanauts to depth to perform meaningful work tasks. There's also a manned diving bell with thrusters, motors, and manipulators. This unit was used primarily in underwater fabrication. It's warm the atmosphere inside and could dive to 250 meters. Alright, so there's a person in there cramped up, as you can see. Probably 3 people. We'll see now, we'll show. Here we go. So 1, 2, 3, 4. At least. You can see the manipulator, okay? Thrusters. So this is the future, what someone thought would happen. Right, just like a regular work site. You know, a big submarine, workstation and all that. Guys and girls out working away like it was nothing. But that's not practical. So now we're getting a Mobot. So 1960, Shell Oil Company transferred Hughes Aircraft's Mobot, originally designed for the Atomic Energy Commission, into the first offshore oil ROV. Right, atomic energy, derived from the bomb, I guess. Once again, military. Here's an early patent for the unit made by Howard L. Shadow in 1965. So Mobot weighed 7,000 pounds. It was a swimming wrench that was hydraulically powered, had steel manipulators, intelligent noise, and was linked by an electrical cable to the surface controller. Mobot worked on 24 offshore wells in depths to 330 meters, over 1,000 feet over the next 10 years. So despite what it looks like, it was pretty good. Because of the necessity to pay traditional divers to rescue and tangle Mobots, early models were known as a diver's best friend. So here we go. The first true commercial ROV, named RCV-125, was introduced to the offshore oil and gas industry in 1974. By 1980, all manned submersibles were eliminated in the North Sea and shortly thereafter in the Gulf of Mexico. Within a relatively short time span, about 6 years, ROVs have proven themselves and were here to stay. So military ROV technology was introduced to the offshore oil industry with the first hydroponics RCV-125 seeing service in the Gulf of Mexico in 1974, followed by RCV-225 and 150. So I would probably say that's 225 and that's the 150. ROV technology improved and their capabilities increased in a wide range of applications. They became more widely used for significant advantages and gradually began to break the stranglehold saturation divers had on the industry. So just a quick brief on safety here. This diver is in the line of fire is called. This is steel, almost like a spear. Right? If you sneezed, you're on the controls of this, or drop the control or whatever, this man could be impaled or crushed, okay? This could smack into him and knock his breathing apparatus or helmet off. So this is a no-no. Okay? From the old days, obviously. So in 1976 and 77, a number of companies, including ISC Limited, based in Port Coquitlam, BC, contributed to the advances of ROV technology with the introduction of the deep drone Scorpio, Scarab, High Sub, and the T-Rav, as seen above during trials on Pitt Lake, BC in 1975. Alright, so I knew a guy that worked with oceaneering from ISC. He was originally from here. During the pioneering days of the 1970s, ROVs were plagued with frequent failures, with actual ROV operation time limited to a few hours each day. The pre-ISC high sub ROVs provide the technical foundation for today's ROVs. Okay, so you can see it, right? Anywhere from like 3.5 to 6 feet high, most are, right, for the work class 3. ROVs and like 5 or 6 feet wide, 8 feet long, roughly, okay? The early 1980s witnessed a period of rapid growth coinciding with the boom in the offshore oil industry. So Richard, the other instructor, this is when he come on the beam. But this time, the second generation ROVs had greatly improved reliability and performance. Excuse me. Most early ROV systems were free swimmers, that is, surface deployed by means of a crane or boom assembly. This was dangerous and often resulted in damage to equipment and personnel injury. So this is back in the day, right? Like no PP, no flotation. sneakers on, right? Now, it looks like he's jumped up. I can almost see a grin. Looks like a wave coming. Something like this happened to us on the Osprey one time. Right now, we never got swept out, but I jumped up on the barrel, laughing at my co-workers who all got water over their rubbers. So, you know, it's 2 feet high or something come in. Always a possibility of danger of being swept out, but that's why you get paid such big money. Alright, so this is before safety, as you can see. So here's a Lars, right? This booms in and out. See the hydraulic actuating rams, right? A TMS top hat type. Right, this is the top hat. So this armored umbilical can be up to a mile long, and this can be, you know, several hundred meters long. And then the ROV just flies away. So this goes down up to a mile, and this flies away up to 500 meters or so, give or take. So operations became safe and less labor intensive, and there was less risk of loss or damage to increasingly more and more expensive equipment. The oil and gas industry collapsed in the early 1980s as a result of the oil glut on the market by Saudi Arabia, which is on the go right now. True research and development R&D was non-existent. Despite the oil industry downturn, RV used continue to grow, primarily in the telecommunications industry for cabling and repairs. Alright, so we'll get into that next week, the cable laying and the trenchers and all that. They can be very big. So by the 1990s, ROV reliability, capability and performance levels have reached the point that the industry began to design ROVs in their projects as a primary operational tool. In fact, today 100% of all offshore drill support operations can be completed with ROVs with no need for saturation divers. However, divers are still required for some complex subsea repairs, primarily in shallow enough water. ROVs have matured to the point that services are available worldwide to support many other industries besides oil and gas, including telecommunications, construction, hydroelectric, survey, search and salvage, and military applications. Alright, so there's a couple of, you know, fish farming is big now, right? Net cleaning. Construction as in like wharfs and all that, eyeballs being used. ASI up in Ontario hires our students, 1 or 2 a year only, but still it's an inspection, pipe inspection and dams. So there's many other opportunities. RV technology is required for new varied applications such as in science, exploration and military use. Alright, so it's also being used like for interdiction of drugs, right, that are probably magnetically held onto a hull of a ship. So high sub 40, 5,000 meters has been forming scientific dives for Canadian Scientific Submersibles Facility, CSSF, since 1996. It's logged more than 13,000 scientific dives and sport of 85 science and engineering trips on 16 different vessels. Has worked in the Pacific, Atlantic, and Indian Oceans. So Robust has been involved in groundbreaking destroyers such as hybrid chemosymbiotic ecosystems such as tube worms and active gas venting at deep sea hydrate mounds. So black smokers is called, okay? So this is fairly deep, to say the least. And what else can I say about that? That's about it. Alright, so that's it for this week. Feel free to research your trade that you're taking. Okay, so research ROV, AUV, and the history, and the potential, and the companies that's involved right now. Alright, signing off for this week's lesson.